Hello and welcome. Today we're going to be continuing our series in machine learning. Today we're going to be looking at clustering. There are various machine learning problems that you can be having. It could be regression, it could be classification, it could be clustering. And we have various techniques and methods that you can use in handling those problems. So today we are going to be using k-means to solve a clustering problem. What is the difference between clustering and classification? In classification, you already have labeled data, isn't it? You're classifying to meet the target. But in clustering, you don't have any labeled data. You simply look at all the data, fetch the similarities and the differences, and be able to partition them. And that is what we're going to be doing today. And we're going to be using our data from income and income data. Let me quickly share my screen so that we can get started. And you all know, if you want to do machine learning, we normally use the Anaconda. So open up your Anaconda, just go to your search if you're using Windows 10. If you had already installed Anaconda, you should be able to see it there and do the right needful. So once I click on this search, I can simply type in Jupyter Notebook. And as I'm typing, I should be able to see my Jupyter Notebook pop up. And that's exactly what I'm going to do. So I'm going to simply type Jupyter. And your Jupyter is Y, not I, so that you don't make a mistake. Jupyter. So as I'm typing, it's going to pop up. You can see it here, Jupyter Notebook Anaconda 3. So I'm going to click on it. Once you click on it, then it's going to open up the Jupyter Notebook. Once you click on it, it's going to first of all bring up these command prompt kind of area. Then after a while, this is what it's going to open up. Then after a while, it will then open up this your Jupyter tree. So to open up your notebook properly, I'm going to go to this new. You can see it here. Once you click on new, click on Python 3. So once you click on that, your notebook is going to open. And like we all know, once our notebook opens, what's the first thing we do? We rename, isn't it, to give the name that is similar to the task that we are performing. So let's open up our notebook. I'm going to name it clustering Augustine. That's the technique I use in naming. So you can also get your own technique. It's always good you give the notebook a name that relates to what it does, isn't it? So that whenever you come to it the next day, you should be able to locate the file and do the needful on it. Okay. So I'm going to wait a minute so that the notebook will open. All the lectures, the codes that we're using, they are all on our website, Tclassified.com. So you can see my notebook is fully open. I'm going to click here. You can see where they wrote on title 1 up here. My own is on title 2 because I already have one on title 1 opened up. So click on it. It's going to bring up a box. So type in this box the name you want. So I'm going to name my own clustering, because that's what we're doing, clustering Augustine. Why am I putting Augustine? Because I know I'm definitely going to create other clustering. So I want to be able to differentiate it from this one. Since this is for practice, when I do a good clustering that I'll be using for project purposes, I should be able to name it clustering without putting Augustine. Okay, so we can then start coding. And like you all know, all the source codes, they are on our website, www.tclassified.com. Once you get there, click on blog. Then inside the blog, you'll see other options. So click on machine learning. You see what we've done so far. We've done all these before. We've done all these. So read it up and follow up. Check out our YouTube channel, Ekene. That's where you see all the videos, so that you follow up the one you did not follow. If you're joining us today for the first time, I hope we can hear me clearly from the earpiece. Diamond, can you hear me? Who is joining up? Who is joining up and is using earpiece? Ola? Okay, so I'm very clear. So let me continue. Okay, we've done all this. We did classification using SVG, support vector machine, yesterday. I hope we all picked up what we did. And we use the data that is already inside SQL. Today we're going to use the data that is from our what? From CSV, isn't it? Excel. So how do you make your data? So this is what we are doing today, clustering with k-means. You can see it here. The table is what? Income.csv, and it's containing columns name for all the names of the people we are looking at, their ages and their income. So this is a typical data science problem. You understand? You have everybody here. Do you know who can pick out this data for all of you here, isn't it? I can tell. What's your name? Joshua. Joshua, what's your age? You tell me. How much are you making? You're making very little. You tell me the amount, isn't it? We can actually pick up this data for you people here. So this data is not looking like something so foreign. It's a data I can pick for all of you, isn't it? So that's how this data was actually gotten from people, you understand, noting their income, because you want to study those people. You want to be able to advise somebody to use those people's data to achieve something, you understand? So collect this information and open up your Excel. Open up your what? Excel. That's how you prepare it. So I'm going to go to my Excel and show you how I got this, how I got put together this my data. So I'm going to go to my Excel so that you can see the data. So very importantly, you have to know where you saved your work, because you know you have to give it the direction of where you saved your work. So I told you guys already to type out this in Excel. So this is how you get to know where you saved it. So what am I using? What's the name of the file? Income.csv. You see, ba? It's the difference between this file and this file. Who can tell me the difference? This link red chart and income.csv. Can you notice any difference? This is a standard Excel, saved as standard Excel, you know, .xlo, blah, blah, blah. But this one is .csv, you understand? So two of them, if you open them, you also see the table. You understand? But the file format varies. What kind of file format do you need for machine learning in Jupyter? CSV, very important. If you don't save in CSV, then you're not going to find it very easy using. You understand? And it's so simple. When you're doing your save as, pick out CSV to save, okay? So I'm going to open up this income, which I actually got from here. This is where I got it. I saw this here. You understand? So I prepared it in Excel in order for it to be used in my Jupyter notebook. So I'm going to let it open up. So once it opens up, then we can continue. Okay, it's opening up. But as it's opening up, let me still get back and continue explaining to you what clustering is all about. Clustering is very similar to classification, only that you don't know where you don't know the level. It's not labeled. You understand? You just look at the features of the data and put them together according to the ones that are similar. Is that clear? Unlike in classification, where you already know where you want to get them to. So it's going to be pretty the same method of doing it. Okay, so you can see this is my data. This is my CSV. Can you see my CSV? This is names. These are ages and income, just similar to what I was given here. So I just took up what I have here, opened up Excel, filled in this data, went to File, went to Save As. This is Save As. Clicked on Save As. Then when I clicked on Save As, then I had to save as what? CSV. But the name is income. Income.csv. So you have to put income here first. Then here you put CSV. Then you click on save. Once you do that, you've done the right thing. Once you do that, you've done what? The right thing. Okay. So for you to be able to read out this very Excel CSV file inside your Jupyter notebook, you need to first of all know where you saved this file. This file is saved here. So I'm going to click here and copy this part. It's inside my C, which is my hard drive, under users, under user, under documents, under desktop folders, under data science. So I'm going to copy this part. So with this part, I can get back to my work. So what is the first thing that was done? We have what? From sklearn.cluster import k-means. Do we see that? The algorithm known as k-means is already written and kept for you. Just import it and use it and do your clustering. So easy. That's why Python is so good. When I was introducing Python to you people, what did I say about Python? I told you guys that Python has so many libraries, that the richness of the libraries in Python, that's what makes Python so powerful. Anything you want to do is almost correct that somebody have already written such code or such algorithm. You understand? You just import and use. You just import and do what? Use. Very simple. You don't have to reinvent the wheel if it is there giving you what you want. You understand? But if what they have is not giving you what you want, that's when you, looking at what they've done, you can improve on it. Is that clear? Okay. So I'm going to make these imports. Who can tell me the 4 things that you must import for you to do machine learning? 4 things that you are likely going to import in order to do machine learning. Who can tell me those 4 things? Joshua, give me one. Pandas, okay. Casimir, one. Huh? NumPy, okay. Ibrahim, give me one. Matplotlib. Sklearn, you understand? Those 4 are so important. And those 4 are what I'm going to import now. So I'm from sklearn.cluster. I'm importing k-means, which is the algorithm that we're going to be using. I'm also importing pandas as PD. Then from sklearn.processing, I'm importing min-max scalar. At some point, I'm going to be using this. Then from matplotlib, I'm importing pyplot as PLT. You see, you can also import matplotlib.pyplot as PLT. So notice that we are just doing the same thing. Still, once you do PLT dot, your scatter is going to plot your scatter. You do it dot x-axis, it's going to put in your x-axis. Put dot y-axis is going to do the same thing for you. Okay, once you make those imports, you can just simply click on run and make sure everything is moving smoothly. So what's the next thing I'm supposed to do? What's the next thing I'm supposed to do? I'm supposed to read out my file, isn't it? And when I read it out, I want to show the head. The head is the first 5 words, columns. Is that what we did? Okay. So let me do that. Yeah. Okay. Sorry. Yeah. That's the way. That's the way to do it.
Yes.
Yeah. So let's continue. Sorry, somebody was talking to me. Okay. What's the problem? Okay. Yeah, let's continue. Sorry, somebody was talking to me. So I'm using pandas in order to make this data frame, isn't it? How am I making this data frame? I'm reading out what is inside my income.csv. You understand? And then putting them in data frame. And that's the use of pandas. Then after doing that, I want to show the first 5 rows. That's what you do. When you say dot head, you're showing the first 5 rows. So if I run this, is this going to work? It's not going to work because this is not, I'm not getting to where I saved my income.csv. So to get it, I simply go to where I saved my file, which is here. So I click, I copy this. This is the directory. So I go back. Then inside here, just in between the quotes, I put this. Make sure I put the backward slash. And make sure I put it in the read mode because it's going to read it. Then I can now run. So having done this, it's going to work. So you can see the first 5 rows. Now, Abraham, what happened with the post-UTME registration? Okay, so you can see the first 5 rows perfectly done. So you can see the use of pandas, PD. We imported pandas as PD. It helps us to do this. It's pandas that help you to make out this table in Jupyter. Is that clear? So that it will look almost similar to what you have in your Excel. We say that statisticians are almost doing the same thing as data scientists, isn't it? It's not that you are a programmer knowing Python. So you have more power than the statistician that could have been using Excel to do his work. So you're doing everything he's doing in a more slick way. Okay, so let's continue. So this is what we've seen. So now I want to plot out the graph. What model do we use in plotting? Who can tell me the model that we're going to be using in plotting? Matplotlib, isn't it? And we already imported Matplotlib. From Matplotlib, we imported what? PyPlot as what? PLT. Okay, so I'm gonna do what? Run this. And I hope we already understand it very well. I know what it does. So what do we do here? PLT X label simply means we want to put the X axis as what? Age. We want to name it age. That's why we're having age. Then PLT.Y label, income in dollars. And that's why we have this, isn't it? So that's what we have. You guys already know this. Then PLT.scatter. Scatter is simply telling us what? We want to plot the scatter plot, isn't it? And what are we plotting? We are plotting the data frame of age, isn't it? At the horizontal axis, and what? DF of income at the vertical axis. So with that, explains this whole code in such a way that you can understand it. And so let's move forward. Let's move forward. Okay. So what's the next thing we're gonna do? This one is pretty straightforward. We don't need to suffer ourselves so much. So let's use the k-means immediately and build out our model, train our data, and test it out. We're not gonna be wasting time in this. We're almost done. So I'm gonna put in this. So KM, who can tell me what KM is there? By now I shouldn't be asking such questions with resistance. KM, what is KM here? You can tell me what KM here is. Joshua, Ibrahim, Fortu, what's this KM? Once you put something and say equal to, that thing on the other side is a variable. You understand? So that means it mustn't be KM. You can call this Olu, isn't it? And say Olu is equal to. What matters is the value. You understand? The value has to be something that is correct. It's either you're importing a model or you're doing something that is correct. But what is on this other side is simply the what? A variable. So you mustn't call it KM. Why did we call it KM? Who can tell me why you call it KM? Because the algorithm we are using is k-means, isn't it? So call it, I told you when you're naming a variable, it has to be related to what is used for. So, but what is on this side is very important. What is on this side is the model. And that model is what k-means, isn't it? K-means with n clusters of 3. Then y predicted, once you say y underscore predicted here, it's also a variable. This is also a variable, you understand? But that is what you're going to be using to do what? Fit your model. That means you're making your model to run. So how do you do that? You simply say km. Why did you mention km? Because this km is already k-means of n cluster 3. Who can tell me why the n cluster is 3, equal to 3? Who can tell me that? Because we want to cluster this into 3 different clusters. Is that clear? If you want it into 5 different clustering, you have to put 5. So we now say km.fit underscore what? Predict. That's the function that does the prediction. Is that clear? So it's going to check at this data frame that has age and income and do the work. Then you are now want to give the answer to the prediction. Who can say, tell me what this array of answers is showing? Who can tell me that? Somebody should think and tell me. You have 0, 2, and 1. Who can tell me the implication of this 0, 2, and 1? Because there are 3 clusters, isn't it? It's either you're in cluster of 0, or in cluster of 1, or in cluster of what? 2. And that is what we have here. You have here, you can have this one as 0, this one as 1, this one as 2. Did you see how this was done? Very simple. Who can give me an example of application of clustering in determining spam messages, isn't it? I told you this. Email vendors like Gmail and Yahoo, that's what they use in determining which one is spam and which one is correct email. You understand? Somebody bombards your email with plenty messages. You understand? The algorithm looks at all the messages. Then he identifies the ones that are similar. Those ones that are always coming from one suspicious address, they put them one side, they are spam. Those ones that are coming normally, they put them one side as good message. That's why when you go to Gmail, Gmail was the first people that started classifying to. If you open your Gmail, there's your normal inbox, there's primary, there's secondary, you understand? Because I told you that Google, they are very good in data science, you understand? They've even used it before. You know, it's Yahoo that started email service. You understand? Google started with search engine, isn't it? But when they went into their own email, everybody wanted to use email. There are some applications that you'll be doing. If you use Yahoo and use Gmail, you see that Gmail receives email first. You understand? Google is very, very efficient. You understand? So you use skills like all these data science algorithms to make your work more efficient. And that is why Tclassified want to rebuild Tclassified website with Python. You understand? So that you can incorporate data science in that website to make the website to be good. I want you automatically, once you just log in, you understand? Instead of going to data science or basic program or JavaScript, I want my website to be able to know that you are interested in Python. You understand? It will show you things concerning Python. If a school student logs into my website, I want what you'll be seeing presented to him to be Jamba and WAEC questions and past questions or lectures. You understand? That's where I'm thinking towards. And that's why I had to rebuild the website with Python and Django. Are we seeing all this? So software development is all about application. Okay, so let's tidy up, let's round up and do other things. Okay, so what else am I doing? Okay, so having seen what my clustering is, I'm gonna simply I'm gonna show you the cluster in data frame so that you look at it and see the way it looks. So let's make out this cluster in data frame. So what I did here is that I created a new column. Is that clear? If you go to this, the previous table that you have, are you seeing the previous table we have? So to create a new column, we already know. It's also df, which is the data frame. Put that column there, which is cluster, then equal to what? Y underscore predicted, which you already got here, isn't it? So it makes it in tabular form. Then when you do df.head, you're simply bringing out the what? The first 5 what? Rows. And those are these. So you can see that these ones that are in 0, cluster, they are the first classification, 2, second classification, and 1, third classification. So let's get going. Okay. So lastly, I'm going to find the centers of these clusters. I'm going to find the what? Centers of this cluster. What is the reference of all these clusters when you go to them? So what's the dimension, or what's the geometry of the center of these 3 clusters that I have? That's what I'm going to find out with this. Okay, so let me find out the centers of my clusters. So for cluster 1, this is the geometry, this is the XY axis, this is for cluster 2, and this is for cluster 3. It's as simple as that. So having found that, I can now make a plot that will show me, give me more information. You see, the first plot we had, we've not classified, we've not clusterized in the first one. But now that we've clusterized, we want to plot now in a better way. We want to plot giving colors and everything, so that once you see a class, you can easily differentiate it from the other cluster. Look at the first. Can you see the first plotting we did? No difference, isn't it? Only that you're able to pick them out based on where the data are, isn't it? But now, if you plot this now, we'll see them with color and everything. You even see the center, everything well highlighted. So if I plot this, okay, so you can see this is one cluster, this is another cluster, this is another cluster. Are we together on this? Are we together on this? So this is the center for this, center for this, center for this. So it's all shown. So let's use this and okay. So I'm gonna stop here for now. Okay, let's quickly use this min max scalar before we stop. So I'm gonna use this. So as you all know, all the codes we are using, get to our website, you see all of them clearly stated and given to you. Okay, I'm supposed to put all this at once. Yeah, I'm having error. Where's my error from? 204 in 204 bar. So let me take it out. Let me run now. Okay. So let me put it here. Take out all this. Run this. Okay. So you can see my clusters. I have this. I have this. I have this. So what does it do? This is simply telling you that Rob and Michael. What's the interpretation of this? Rob and Michael, they are in the same class for income, isn't it? Mohan and Ismail are in the same class. Corey is in the same class. Can you see the clustering? Can you see the application? Now, if you're looking for people that have the income value of 0.3, 0 point something, 0.3, 0.2, is that clear? Rob and Michael, they are in that range. If you're looking for people that have income of up to 0.8, Corey is in that range. If you're looking for people that are in the range of 0.1, 0.1, Mohan and Ismail are in that range. So you see how clustering is able to help you put them together. You understand? When you collected this data initially, this is the data you collected. Let me remove this DF head so that you can see the whole data that you collected. Run. This is all the data you collected. Is that clear? So you see people having 7,000, when you're collecting, you're not checking to know the classes. You understand? What is the income level of these people? You're not checking it. You just go, you call this person, it tells you your income. You understand? Then somebody comes and tell you, what is the income range of the people inside this class? You understand? Instead of going back to the table and checking it one by one, you can use k-means to classify them already. You understand? So k-means is able now, because you're using 3 clusters, cluster them into 3 places according to similar ones. Is that clear? If somebody is having income of 7,000, you cannot expect the person to be in the same range as somebody having income of 13,000, isn't it? So what this clustering does is that it's going to separate it for you. So all the people having similar income will be on cluster 0. People having similar income will be on cluster 2, and people having similar income will be on cluster 1. Is that clear? And that is actually how the mailing spam mail happens. You understand? People with similar characters are classified in one, so that you know where to send them and where not to send them. So if I now come to this class and ask you, who is likely having the same salary as Rob? Who will tell me who is having the same salary as Rob? Michael, because they are in the same cluster, isn't it? Who is having the same salary as Ismail? Mohan, because they are in the same cluster. You understand? That's the work. That's just the work of this clustering. So that you get people with similar characteristics and put them together. And that's how we're going to be ending today. Please, like I always say, everything you want is in Christ Jesus, and the easiest way to success is by being a born again. See you when I see you. Love you. Thank you. If you have any questions and concerns, drop them in the comment section. Thank you.